Hello, I'm Xiaofei. I would like to tell you about our work on gold nanoantennas for generating photon pairs for quantum imaging. This is a technique presented by researchers in the Dillinger group recently, and it is technically very interesting because you can image an objective in the infrared while detecting only visible photons, where detectors are best. For this, you only need a good source of photon pairs with one photon in the visible and one in the infrared, and we want to build such a source. On the top right, you can see our design. We have 3 resonances such that you can pump at 850 nanometer and get pairs at 550 nanometer and 1550 nanometer. Of course, in the future, we would like to push this further into the infrared, where many molecules have characteristic absorption bands. For our characterization, we make use of a technique called stimulated emission tomography, SET. The basic idea is to study a spontaneous process such as SPDC, which delivers photon pairs indirectly via the corresponding stimulated process, DFG. In order to estimate the SPDC pair generation rate, you need to divide the DFG signal by the number of photons that were used for stimulating the process. So far, we could apply this technique to a sample that were used for nonlinear frequency mixing studies previously. The framework is established now, but the best we could get out of this old sample is an estimated SPDC pair generation rate of 0.4 Hz. So we want to use our new antenna to increase this efficiency. We have not measured DFG yet with it, and not directly compare the samples, but we could show that the new sample does indeed support frequency mixing processes such as SHG, DFWM, and SFG, which is the inverse of DFG. DFG is experimentally more challenging because you have to detect in the infrared, but we are confident that we can find and characterize this signal soon. And this is where we are currently at with our project. I'm looking forward to your questions.